We'll solve a problem here. The problem consists of an electric light fixture. This is the electric light fixture, which is supported by two ropes. One is BA and the other is BC. Okay. We are required to find the tensile forces in the ropes BA and BC. For convenience, let us say S1 is the force in rope BA and S2 is the force in rope BC. Now we have to draw a free body diagram and establish the condition for equilibrium. We are saying equilibrium because once the electric fixture is hung, it is going to be in equilibrium under the action of three forces, that is the force Q, which is the weight of the object, S1 and S2. Obviously we need to draw a free body diagram of some object, and from that object derive the condition for equilibrium, and from that condition find S1 and S2. To find out what is that object, notice the sketch carefully and try to find out which object is touching the unknowns. If we clearly see this ring at B, okay, the ring to which the ropes BA and BC are attached and the light fixture is attached, that ring is touching the ropes S1 and S2. So we'll try to draw the free body diagram of the ring at B. Okay, so we draw this ring, okay, and try to identify all the forces that are coming onto this ring. One force is the weight of the fixture, and we know this weight of the fixture Q is 178 newtons, is acting down. Another two forces are, one force is S1, another force is S2. Okay. Now what remains is to fix the directions of S1 and S2. See what this ring is doing to S1. This ring is pulled down by a force Q. So this ring exerts some force on the rope BA and exerts some force on rope BC. If we see that one component of this force Q is pulling the rope BA down as shown by this arrow. So what will the rope in turn do? It will exert a force opposite to it, okay, opposite to it along the rope. So the direction of S1 is indicated here. Similarly, you can say that the direction of force of rope BC onto the ring is indicated here. Once we do this, we'll show all the angles. This angle is 60 degrees. So you can very clearly see that this angle will also be 60 degrees. If you try to extend this vertically up, okay, since this is whole angle is 90 degrees, this angle will be 30 degrees. Similarly, try to show the other angle given. This is 45 degrees, okay, and thus this is 45 degrees, okay, and if you complete this little triangle, this angle will also be 45 degrees, okay, and we know this is right angle, this is right angle. So we know all the angles between the forces. This whole angle from here to here is 90 plus 45, 135. This whole angle from here to here is 90 plus 60 degrees, which is 150 degrees. Once we have all these angles indicated correctly, all we need to do is invoke Lamy's theorem. which deals with three forces keeping a body in equilibrium. The three forces are Q, S1 and S2. So this Lami's theorem as applied to this case would mean Q by sine 75. We have 75 because it's 45 plus 30 is equal to, have S1 by the angle between the other two forces is 135, sine 135 is equal to S2 by the force between the angle between the other two forces is 150 degrees, sine 150, from which we can compute what is the value of S1. S1 is Q is 178 divided by sine 75 multiplied by sine 135, which is equal to, let me quickly bring a calculator. Okay, 178 divided by 75 sine multiplied by 135 sine is equal to 130.30 newtons. Similarly, you can find value of S2 to be 178 by sine 75 multiplied by sine 150, which is equal to 178 divided by 75 sine multiplied by 150 sine is equal to approximately 92.14 newtons. Okay, in most of the problems the method is the same. Finer details here and there may be different, but you try to draw the free body diagram of a critical object, and from that establish equation of equilibrium, and from that solve the unknowns. Okay, we'll try to solve a couple of more problems and try to see a bit more complicated situations involving three forces to begin with, and then more number of forces in subsequent classes.